Hello, and welcome back to another IB Math speedrun with me, Vince. In this speedrun, we're going to be going through chapter 9.4 of the textbook, which is all about the vector equation of a line. So let's jump right in. So there are actually three ways that we can express the equation of a line in vector form. So the first one is called the vector equation of a line. And this one is where we have any point on the line, xy, is equal to a certain starting point, x1, y1, plus k times d1 over d1, d2, where this is the direction vector and this is just a point on the line. So we can define any line by using a direction vector and one point on that line, and any vector parallel to that direction vector will define the same line. So this form is also often written as P is equal to A plus KD. So yeah, that's the vector form. Next, we need to talk about the parametric form, which is where we split it into x and y components. So this will be like x is equal to x1 plus KD1, and y is equal to y1 plus KD2. So as you can see, this is just splitting the vector into its individual components. And finally, from this, we have the Cartesian form, where we eliminate k. So we have x minus x1 over d1 is equal to k. But this is also equal to y times y minus y1 over d2. So this is where we express the equation as x minus x1 over d1 is equal to y minus y1 over d2. And you might recognize that since this is a linear line, we have the we have the gradient as equal to d2 over d1. So yeah. So that is the vector equation of a line, and then a normal vector, or a vector normal to this line, is perpendicular or orthogonal to any vector on the line. So this is the normal line. This is AP. Well, then n dot AP is equal to 0. So, I mean, this kind of follows that n dot the position vector of P minus the position vector of A is equal to 0. So we can also split it into n dot P minus n dot A is equal to 0. And of course, the normal vector will have a vector with a direction vector with equation d2 over negative d1. And so yeah. Now I think we can jump into some questions just regarding the things that we've covered. So the first question is, find a vector equation of the line passing through the points 0, 0, and 2, 3. And to find the vector equation of a line given 2 points is relatively easy. What we do first is we subtract the 2. So we go b minus a, position vector of p minus the position vector of a to give us the direction. In this case, the direction will simply be 2, 3. And then we can simply go xy is equal to k times 2, 3 plus one of the points. So in this case, I'm going to pick 0, 0, so it's simply plus 0, 0. If we also, it's the same thing if we put 2, 3. We just need to put any point on the line in this other vector. So this is correct. Okay, on to the next one, where we have, we need to find a line that passes through -2, -5, and f is 3, -6. So first let's get the direction vector. So we have k, and then we have 3 minus 2 is 5, -6 minus 5 is -1. So we have xy is equal to k times 5, -1, and then we can simply add one of these existing points. We'll pick this one, which is -2, -5. And so yeah, this should be all good. Okay, on to the next one, where we need to find an equation of the line that's passing through point P of 2, -7, that has a direction vector of I plus j. So if we have a direction vector of I plus j, and it's passing through this point, well, we can simply say that the line is equal to, well, what's this in vector form? This is equal to 1, 1 plus 2 minus 7. And that's pretty much it. And so if we want to find the actual equation, though, we want to convert this into a Cartesian form, into parametric equation and then Cartesian. So first we have x is equal to 2 plus d1 plus k, and y is equal to negative 7 plus k. So then we have, therefore, x minus 2 minus 7 is equal to y, so y is equal to x minus 9. This is the equation of the line. Okay, on to the next one. And the last question, actually, quite a short one, is the line L is equal to x minus 3 over 2 equals y plus 1 over minus 3. And the point t, which is at negative 3, 8, are given. Find a vector equation of a line that is first parallel to the line L passing through the point T. Next, perpendicular to the line L and passing through the point T. And C, passing through the point T and the intersection between the line L and the line R is equal to 1 plus 2 lambda I plus 4 lambda minus 1 j. So let's do these in order. First, I'd like to convert this I guess Cartesian equation into a vector equation. So we can tell this is of the form k is equal to x minus 3 over 2 and k is equal to y plus 1 over 3. So what we have here is x minus 3 is equal to 2k and y plus 1 is equal to 3k. And so therefore we have xy is equal to k times 2, 3 plus the vector of negative 3 and 1. Okay? Vector equation of a line that is parallel to the line and passing through the point T. So if it's parallel to the line, it has the same direction vector, and it's perpendicular to the point T is negative 3, 8, we can simply substitute negative 3, 8 in here. So this is the first line. This is the first line over here. So we would just change the point on the line from negative 3, 1 to negative 3, 8. Sorry about that. I just didn't transfer the minus sign over. That's why I was getting a little bit of a mistake. Anyways, negative 3k. So we have k times 2 negative 3. And the book gives a different answer, but since the direction of the vector is the same, it's all good. Next, perpendicular line, I believe, passing through the point T perpendicular to the line L. So if it's perpendicular to this line L, then it would have a direction vector of 3, 2. Yeah. And it passes through the point T, so that would be negative 3, 8. And this is simply equal to xy. So this is already the second answer. And so finally, I think we have a slightly harder one. So it passes through the point T and the intersection between the line L and the line R. So R is equal to, let me just rewrite this. R is equal to 1 1 plus 2 lambda I plus 4 lambda minus 1 j. So if we want to rewrite this in vector form, this is equal to xy is equal to 2, 4, k, or lambda, let's say lambda, plus 1 minus 1. So we need to get the intersection between these two lines. So we have so I guess we can convert into Cartesian form. So here we have x is equal to 2 lambda minus plus 1, y is equal to 4 lambda minus 1. And so we have eliminate lambda, x minus 1 over 2 is equal to y plus 1 over 4. So we have 2x minus 2 minus 1 is equal to y is equal to 2x minus 3. And the other line we need to intersect it with is x minus 3 over 2 plus y equals y plus 1 over negative 3. So x minus 3 over 2 plus y is equal to y plus 1 over negative 3. So then we have negative 3x plus 9 is equal to 2y plus 2. And so we have y is equal to negative 3 halves x plus 7 over 2. So equating these two together, we get 7 over 2x is equal to 13 over 2, x is equal to 13 over 7. The book's made an error. Okay, well, the book has made an error, so I'm going to go with my answer, x equals 13 over 7. Why? Because the book assumed that this is 2x minus 3, which it's not. So y is equal to 26 over 7 minus 3. So 26 minus 21 is 5 over 7. So if we plug this into the equation over here, 13 over 7, 5 over 7, and we need to get this. So it's between this point. We need to get the equation of a line that goes through this point and this point, negative 3, 8. So we can get this column vector of 8 minus 5 over 7, which is 56 minus 5 is 51 over 7, and then negative 3, sorry, that's the y value. 51 over 7, and then we have 21 plus 13 is negative 34 over 7, k, plus the point 3, negative 8. So we have x and y is equal to this. Nice. So that was all for the speedrun. Oh, wait, nope, it's negative 3 and 8. Anyways, that was all for the speedrun. I hope you enjoyed, and I hope to see you in the next one. See you then.